Hi folks, welcome back. If you're just joining me for the first time, I did a refresh on factoring on our last lesson. Today I'm going to introduce Chapter 10 or Unit 10. If you're following along from the Anchorage School District, you're probably in this book, but I'm not going to go specifically from that book because this is going to be helpful for everybody involved. So today we're going to talk about graphing quadratics. Now remember, a quadratic is something that you, it's a x to the second power. X to the second power, let me back that up a little bit. See my face. There we go. So here's how we're going to go about doing this. So we're going to talk about our parent graphs here. Parent graphs. This parent graph that we're going to be talking about today is y equals x squared. Y equals x squared. Now, you can always do an xy chart for most of the time. You can do an xy chart for graphing. I'm going to teach you an easier way to do this today, though, especially because math is all about patterns, and there's some patterns in here that are really neat. So let's do this. We're going to do -2, -1, 0, 1, and 2. All right, so if I substitute in -2 for here, remember when we're dealing with negatives and especially exponents, we got to use these lovely parentheses. So I get quantity -2 squared, which would be +4. Now if I plug in -1 here, I would get quantity -1 squared would be +1. Plug in 0, 0 squared would give me 0. 1 would give me 1, and then 2 squared would give me 4. So what that looks like is this. We go like this, and then we go over 2 up 4, and then over there. Now, this is our parent graph. This is our parabola for y equals x squared. This is the base of what we do everything off of. There's a neat pattern here that I want you to pay attention to. You start, this guy's called your vertex, right? It's right at the bottom. It's super important because if you're only graphing like 1/2 of your parabola, it's not going to be helpful. You need to know where that vertex is. So half the time when we're graphing these things, the very first thing you want to do, find your vertex. Also, I love wooden pencils, so I use them, but I have to sharpen them. I'm sorry, guys. The vertex is right here. Now notice this pattern. We went from our vertex, we went over 1, up 1, and then we went over 1, and we went up 3. That's going to come up later. I bet you're going to identify that pattern later. So here's what's neat about that. All right, so now that we know that this guy exists, let's say I do y equals, let's do this, y equals x squared minus 2. X squared minus 2. Well, this is going to be our parent graph, x squared, but we're going to go down 2. So we go down 1, 2. Now that same pattern emerges. Over 1, up 1, over 1, up 3. Over 1, up 1, over 1, up 3. You notice at our vertex, right? Whatever's happening on one side of our vertex, we copy over to the other side. It's symmetrical. So it's helpful to know, okay? So really, you only have to find the vertex, figure out what's going on one side of those things, and then flip it over to the other side, right? Guys, I'm lazy. I'm going to show you the easiest way to do things. So that's my easy way of doing these. So this guy tells us up or down. Up or down. Okay, so then let's take a look at that next one. Let's try this. Now we're also, oh, that was a terrible not straight line. Man, like 15 years of doing this, you'd think I'd be able to draw a straight line. I cannot. Okay, so we're going to do y equals x minus 2. Let's do minus 3 squared minus 2. So I'm still doing that minus 2, right? That tells me it's going to go down 2. I know that. Now, this thing in here is going to tell me left or right. Trick. It is always the opposite. 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 So this is negative. That means we want to go in the positive direction 3. So we're going to go down 2 and in the positive direction 3. Positive direction 3, down 2. Bam, our vertex is right here. Now, we don't have anything in front of our x squared here, and we don't have anything in front of our squared garbage here. Well, we do. We actually have 1, right? So if it's a 1, that just means that the pattern's going to be the same. Over 1, up 1, over 1, up 3. Over 1, up 1, over 1, up 3. Bam! Look at that. Okay? Now, let's say you don't remember the pattern, right? You look at this and you're like, I don't remember what that pattern is, so let's draw another one of these guys here. Okay, so we're going to do this guy. Y equals x minus, or plus 2 squared plus 3. Y equals x squared plus quantity x squared, or x plus 2 squared plus 3. Opposite this, regular this. That means this is going to be negative 2 comma 3 is our vertex. Negative 2 comma 3. So we're going to go over negative 2, and we're going to go up 1, 2, 3 right here. Okay, so that is our vertex. Now, what I have to figure out is if I figure out what happens here and here, I can copy it to the other side. So let's do an XY chart here, right? X, I'm going to erase some of this. X, Y, bam, bam, we have. So it's currently on positive 2. Now I need it to be, oh, wait, it was a negative 2. What did I do? Y'all, making things up as I go along. Why did I go in the positive direction? It's negative 2. Okay, so let's try that again. So our vertex is over here, negative 2, then up 3. 1, 2, 3. All right, so I'll make our XY chart over here. X, Y, the very first thing we said is when we put in negative 2, we get 3. All right, so let's put in negative 1 now, negative 1. So what we're going to do is we're going to substitute negative 1 into here. So what I have is, I'll do that right over here. Y equals, and instead of x, I'm going to put negative 1 plus 2 squared plus 3. Negative 1 plus 2 is 1. 1 squared is 1, so we get y equals 1 plus 3, which is 4. So when we go over negative 1, we go up 1, 2, 3, 4. Okay? That means since this is our vertex, on the other side, it's going to be right here. We don't even have to plug that in, right? Super easy. Y equals, and instead now I want to pick 0 because I want to see what happens here. So I'm going to do 0 plus 2. Again, I'm just plugging in for x over here. 0 plus 2 squared plus 3. 0 plus 2 is 2. 2 squared is 4. We get 4 plus 3, which is 7. When I plug in 0, I have 7. So I go over 0, up 1, 2, 3, 4, 5, 6, 7. Bam! Look at that. It's right there. Now, because that happens over here, we go over 1. Now, take a look. That is from plugging and chugging. Find your vertex and then plug and chug. But look at our pattern. Here's our vertex. We went over 1, over 1, up 3. Okay? So it's good to be able to identify that pattern. All right, so let's talk about what happens when it looks like this. So actually, let me back up here and say, so for standard form, for a quadratic, it is y equals, actually, let's not talk about that yet. Let's go back and do this. You'll see that I have printed out a worksheet down below. Graphing quadratics looks like this. Now you're able to look at these and you're able to identify the vertex on these guys. So I'm going to go through this. So the vertex on this guy is, we know it's opposite this, regular this. Let me move this down a little bit more. Okay, so, okay, so opposite this, regular this. So our vertex is going to be negative 4, negative 3. Okay, let's look at this one. Our vertex here is going to be opposite this, regular this. So it's going to be 1, 1. Our vertex on this guy, negative 3, negative 3. All right, now do 4 through 6. Pause the video, do 4 through 6. Make sure you understand this. And then come on back. All right, vertex is going to be negative 3, negative 1. Vertex is going to be negative 1, negative 4. I do make mistakes in these videos, so if you guys catch them, make sure to tell me in the comments below. Negative 4, negative 2. Awesome. Now that we have our vertex, take a look at all of these guys. This is actually called vertex form of a quadratic, and it's because it's in vertex form. You can find the vertex super easily. In all of these, you'll see we don't have anything in front of our fraction, or in front of our parenthesis. That's what that is, our parenthesis there. This is what it looks like when you do. Here's like a, nope, helpful, I actually showed it. Negative right there. Let's try doing this. Let me know in the comments if this is not helpful, like if it's too close, too far. Here's another one that has an A. Do you see there's a 3 there? This one has a negative. Guys, those negatives, if you have a negative in front, all it means is it's just opening downward, okay? Keep that in mind. Negative 2, so this will open downwards, but that's got an A in front of it. That's something other than 1. Well, if your A is 1, and that's what we call this guy, A, If it's 1, you're easy, you've got your pattern. So let's start by this. Over -4, down 1, 2, 3. There is our vertex. We know that our A is 1 here, so we have our normal pattern. Over 1, up 1, over 1, up 3. Over 1, up 1, over 1, up 3. Now, if you forgot that pattern, again, you can do an XY chart and plug things in. Sure enough, if we plug in -3 up here, -3 plus 4 would give us +1. 1 squared is 1. 1 minus 3 is -2. So when we plug in -3, we get -2, okay? Let's take a look at this. 1, 1 is our vertex. Now we look at our A. Our A is 1, so we're going to go over 1, up 1, over 1, up 1. I'm sorry, let me say that again because I don't want to do both sides at the same time. So from our vertex, we go over 1, up 1, over 1, up 3. Then we copy it on the other side. Over 1, up 1, over 1, up 3. Bam! Look at that. Let's try that again. Try 3, 4, 5, and 6. Pause the video, try those, and then come on back to make sure if you want to pause them and then come on back to make sure you got it, or if you still need the help, hang in there. Okay, so -3 is over -3 down 1, 2, 3. We look and our A is 1, so we are on our normal pattern. Over 1, up 1, over 1, up 3. Over 1, up 1, over 1, up 3. Okay. All right, so then on this guy right here, we've got over -3 down -1, and we look for our A. It is 1, so our pattern is over 1, up 1, over 1, up 3. Over 1, up 1, over 1, up 3. Bam. All right, I think you got the idea on these guys. The answers are also posted down below too, so you can double check your work. All right, so let's talk about how that applies to some of these other things here. Give me a sec. All right, so let's talk about when that A is not 1. When that A is not 1, that is going to be, all right, so when we know that the A is 1, here's our parent graph, y equals x squared. Hold on, I'm going to pause and draw some of these. Okay, so I didn't think you'd want to sit there and watch me draw, so I did that and then paused it and came back. That's all I know how to do on these things. Pause and come back. All right, so y equals x squared. This is our parent graph, right? So we start at 0, 0. We go over 1, up 1, over 1, up 3. Over 1, up 1, over 1, up 3. Just like we did at the beginning of this video. Okay, so now let's talk about when we have an A. Let's do this too, right? I've got these same basic ones here. I'm going to plug these guys in. 0 squared is 0 times 2 is 0. So we know that's going to be 0. -1, quantity -1 squared is 1. Times it by 2, you get 2. -2, quantity, if I put a -2 here, -2 times -2 is going to be +4 times 2 is 8. 1, same thing. I get 2. And if I put a 2 in here, I get 4 times 2 is 8. So let's go ahead and graph that. We've got 0, 0. Then we have over 1 up 2, okay? And then we go over 2 up 2, 4, 6, 8, okay? On this side, same thing. We go over 1, up 1, or up 2, I mean, and then that's 4, 6, 8. Beautiful. So we still have that symmetry on the other side. So this is what it looks like when it's a 2 in front there. Now compare it to our parent graph. Do you see that it's skinnier? It's stretching up higher. The larger the number, the skinnier your graph is going to be, which is kind of weird because you'd think it'd be the other way around. It is not. So the larger your number, the skinnier it's going to be. Let's take a look at these patterns. Remember, it was over 1, up 1, over 1, up 3. Take a look over here. Over 1, up 2, over 1, up 6. We just take our pattern that we had, over 1, up 1, the 1 and the 3, and we multiply it by whatever our A is. And we get 2 and 6. So let's try that with this guy here. This is now less than 1. So for this guy, we have y equals parentheses, oh, whoops. Wow, I'll just leave it. 1/2 parentheses squared. So let's say I put in -2. Quantity -2 squared is going to be +4. Half of 4 is 2. -1 squared is going to be, quantity -1 is +1 times 1/2 is going to be 1/2. 0, we're going to get 0. 1 squared is 1, we get 1/2, and then we get 2. All right, so we've got, and then we get 2, because if we put in 2 here, we get 4, half of 4 is 2. All right, so let's try this guy. We go over 0, 0. We go over 1, we go up 1/2. 1/2. And then for 2, we go up 2. Up 2. So the smaller the number, the fatter or compressed, the more compressed it's going to be. It's squishing down, right? Now take a look here. Let's look at that pattern. This is 1/2. This is 1 1/2. Now, what we've done is we took our 1 and our 3 and we've multiplied it by our 1/2. Again, totally feel free to use an XY chart. That's no problem. So now that you've seen the difference of these two guys, let's talk about how when it's in vertex form, you're gonna, making a mess of here. When it's in vertex form, you are going to, how that A is gonna affect things. First things first, that negative sign just means that it's opening downward. I'll sharpen my pencil. Okay, so taking a look at this guy, we've got our vertex again is going to be opposite this, regular this. So -4, -2. So we go over -4, we go down -2. Now, because this is a negative, it's going to be opening downwards. It's a -1, and so since it's 1, it's going to be our base pattern. We're going to go over 1, down 1, over 1, down 3. Over 1, down 1, over 1, down 3. And there we have it. Bam, that's all that negative means is we're flipping upside down. All right, so pause the video, try number 13, and then come on back. Vertex here is going to be -3, -3. Good. Now, this is a negative, so it's going to open downwards, and it's a 1, so it's our normal pattern. Over 1 up, or over 1 down 1, over 1 down 3. Over 1 down 1, over 1 down 3. All right, so let's talk about what it looks like when it is, now this negative tells us it's going to open down, right? But let's talk about when we have an A here that is not a 1. This time we have a 2. So we've got our vertex here is going to be opposite this, regular this. So +1, 1. We know it's going to open down. So we go over 1, up 1. There's our vertex. We know it's going to open down. Now, normally we go over 1, down 1, but we're multiplying that by 2. So we're going to go over 1, down 2. And normally we go over 1, down 3, but we got to multiply that by 2. So it's going to be over 1, down 6. 1, 2, 3, 4, 5, 6. Bam, just like that. Now, what happens on one side happens on the other. Now, what does that mean? That's symmetry. Well, we'll come back to that, actually. So now it's all nice and stretched out because it's larger than 1. So it's a skinnier guy here. Let's talk about 3 here. Let's not talk about 3 yet. Let's do this one. Same idea. Our vertex is 4, -1. So we go over 4, down 1. This guy is going to open downwards, and our pattern is going to be multiplied by 2. So we go over 1, down 2, over 1, down 6. 1, 2, 3, 4, 5, 6. Over 1, down 2, over 1, down 6. Bam. So much faster if you can identify those patterns. Now, than doing an XY chart. With that said, a lot of times, if you have a real wonky number here, or your vertex is a real wonky number, like some crazy decimal, plug and chug. You pick some numbers, make it happen on one side, copy it over to the other side. Let's talk about that. I keep saying our vertex is symmetrical, right? That's the symmetry. That is, where your vertex lands is your axis of symmetry, but we write it as a line. I'm lazy, I write AOS for axis of symmetry. Here, what I'll do is plug that in, right? I'll call it axis of symmetry. Oh my gosh, you guys, this spell check has totally destroyed me. Axis of symmetry is always written as a line. We write vertical lines as x equals. X equals wherever it crosses on the x-axis, which is -4. So your axis of symmetry is -4. Notice that's your x in your vertex, right? It's the first one because you're going over that many and then down. So your axis of symmetry is going to be x equals 1. And sure enough, you'll see we have a nice dashed line. Whatever happens on one side happens on the other. Your axis of symmetry here is x equals -3. Axis of symmetry here, same thing, x equals -3. So you get the idea on those guys, okay? So let's go back to this one that we were just talking about. Our axis of symmetry here, actually, let me do that. Yeah, let's do this one. Our axis of symmetry is going to be x equals 1. Our axis of symmetry is x equals -3. Awesome. We've got this. Let's try some more of these problems. All right. So when it's in vertex form and you have that pattern, you've got it. You know how to do these things. Like, let's look at this 2 here, right? 2, it's -3, +3. So our vertex is going to be -3, +3. Over -3, up 3. 1, 2, 3. Okay, so then, sorry guys, my dog tried to interrupt. All right, so we go over 3, up 3. Now, this is going to go facing upwards because it's positive, and our pattern is going to be our parent graph, but multiplied by 2. So we go over 1, up 2, over 1, up 6. 1, 2, 3, 4, 5, 6. Over 1, up 1, and then over 1, up 6. I think I said 1, but I meant 2. Over 1, up 2, over 1, up 6. All right. Bam. Look at that. You have graphed this without having to do an XY chart. So like I said, sometimes they're real wonky and you've got to do an XY chart. In that case, just do it. Now, these guys right here. So this is all called vertex form, right? This is called standard form. Standard form, beginning on number 20. I'll put 2 versions of this worksheet down below so you can practice till your heart's content. Ax squared plus bx plus c. This is not easy. We can't look at standard form and easily identify what the vertex is. So what we have to do is we do our first part for our vertex is x equals -b over 2a. Our b is our middle term that comes next to our x, right? So in this case, our b is -2. Well, -2 is going to be +2 over 2 times a, which is 1. Our a is right in front here. That's going to be 1. That gives us 2 over 2, which equals 1. So for our vertex, we have the first part. We have 1. In order for us to find the other part of it, now what we have to do is we take this guy and we plug that x in. Y equals, and instead of x, I'm going to do 1 squared minus 2 times 1 minus 3. 1 squared is 1. Minus 2 times 1 is 2, minus 3. So add the opposite, I get 1 plus -5, I get -4. So when I plug in the vertex for 1, I get -4, -4. So our vertex here is over 1, down 4. Now, again, your a is what comes in front of your x here. Your a here is 1. You could pick 2 points, like 2 and 3, and plug those into this guy, and whatever you get, you copy on the other side of your vertex, right? Or you can remember, hey, this is a 1, so my parent graph is over 1, up 1, over 1, up 3. Over 1, up 1, over 1, up 3, and bam, you have graphed this guy. Look at that. Beautiful. Let's try another one. We've got this. Oh, let's try this one. This looks fun. Okay, so to find our vertex, the very first thing we do is x equals -b over 2a. That is going to be this is +6, so we're going to do -6 over 2 times 1, which is our a, right? That's going to be -6 over 2, which gives us -3. So the first part of our vertex is -3. Now we got to go back and plug that in. Y equals -3. Make sure you use parentheses when you're dealing with negatives and with exponents. +6 times -3 plus 13. All right, quantity -3 squared is 9. Y equals 9 plus -18 plus 13. So that's 9 plus -5, right? So y equals 4. So when we have -3, we get 4. Over -3, up 1, 2, 3, 4. There is our vertex. You could plug in -4 and -5 into each one of these, and whatever you get, you copy over for -2, -1. You could also plug in -2, -1. However, we look at this, we see, oh, our pattern. We can do this. Over 1, up 1, over 1, up 3. Over 1, up 1, over 1, up 3. Fantastically, you graphed it without having to do that. Isn't that nice? That's always fun. Okay, so again, let's find our vertex on this guy. Our vertex is gonna, I'm gonna change. Let's see, yeah, let's do this one. Let's find our vertex on this guy. Okay, our vertex is gonna be x equals negative b over 2a. So that's gonna be negative 8, which gives us positive 8, over 2 times 1, which is a. That gives us 4. So we plug in 4. Y equals 4 squared minus 8 times 4 plus 12. That gives us 16 minus 32 plus 12. Negative 16 plus 12. Y equals negative 4. So 4, negative 4, over 4, down, negative 4. Bam! We look for our A, and we know our pattern is over 1, up 1, over 1, up 3. Over 1, up 1, over 1, up 3. All right, so that's how you find the vertex on standard form. Let's do one that has an A that is not normal. Ooh, look at this guy, number 31. 31 has an A of 2, so that's going to be our multiplier, right? First things first, x equals negative b over 2a. X equals negative 16 over 2 times a, which is 2. Negative 16 over 4 is going to give me negative 4. So the first part of our vertex is negative 4. Okay, now let's plug it in. Y equals, I need another pencil. This is driving me nuts. Y equals 2 times negative 4 squared plus 16 times negative 4 plus 36. Darn it, I squished that all the way over. Quantity negative 4 squared is 16. 16 times 2 is 32. So we get 32 plus 16 times 4 is 64. I don't know why I started to doubt myself. So negative 64 plus 36. All right, so 36 plus 30, what am I doing? Y equals 32 plus 36, 6, 7, 8, 68 plus negative 64. That gives me Y equals 4. All right, so we come back up here. We're like, all right, so you can see plugging in those numbers gets really annoying. You're going to need a separate sheet of paper if you're going to plug it in every time and not deal with that pattern, okay? So we go over here to our vertex, negative 4, up 4. Bam, just like that, okay? Now we look at this guy and we're like, okay, our pattern is going to be multiplied by 2. So over 1, up 2, and over 1, and instead of 3, we're going to go up 6. There's 3, 6. Okay, over 1, up 2, over 1, up 1, 2, 3, 4, 5, 6. Excellent. All right, guys. So that was a terrible parabola. Sorry about that. Same thing for these ones down here. Do you see how it's negative? That just means it's going to be facing down, but that multiplier is still the same. If you guys have any questions, this is a pretty lengthy video, but it's a really good introduction into quadratics. So if you have any questions, please ask them below, email me, whatever you got. And then I will put 2 worksheets. This will be the first one is the one I'm working on, and then the second one will be a different version of that. So if you have any questions, let me know. Otherwise, thank you for listening in, and we'll talk to you soon.